spending your evening with us. Really appreciate it. I know it's not optimal time to be outside anyways, but I hope you enjoyed the sandwich. Today I'm going to talk about software testing, right, and how we can think of it differently. And the reason really I wanted to talk about this topic was just to give you a little bit of a background. Right? Sorry, I'm having a little technical difficulty here, so.
No dead air.
Actually,
So, you know, so a little bit of background. I've been a software engineer for quite a bit of time, and back in 2006, Oracle acquired a company I worked for. And so I was like, you know what, I'm just going to go and see what the opportunities are out there. And so I went on interviews, and I quickly learned that I didn't know anything about software testing. Mainly because one particular interviewer said to me, you don't know anything about software testing. And so it became quite apparent and a humbling experience. And so after that experience, I spent quite a bit of time trying to understand more about it, learn more about it. And eventually I got pretty good at it, and to the point where I was actually teaching other people in our team and then within our groups. And so I became fairly confident as a practitioner of software testing. But I was really never satisfied with the way things work. And then eventually I joined a company where I actually worked with an individual who said to me, I don't believe in software testing, which was kind of a strange place to be. It was kind of, whoa, what have I gotten myself into? And I was like, you know, maybe there's a logical reason why this person believes that. Is there a valid study that I can point him to that says, you know, there's value in it? And it turns out there's really not much empirical studies in software testing out there, right? With scientific method employed, you know, control groups, none of that, right? So there's a lot of surveys, lots of anecdotal stuff. You know, Google has its own, Microsoft has its own study or survey. But there's one really interesting one that was done by the National Science Institute of Technology, right? And what it turns out that really what most developers really care about is tools and infrastructure, and the lack of tools and infrastructure in the software testing domain. And when I say tools and infrastructure, is how do I actually do real-time testing, regardless of what kind of test that I'm writing, right? And how do we do that? And so for me, that was really the catalyst for a project that I started working on, and we'll talk about it tonight. The current state of affairs is that we don't have, in Java, we don't have java.test, right? We don't have it. It's actually worse than that. We don't have javax.test, right? Why do we not have this, right? Why is there no, there's all sorts of APIs and there's no API for writing tests? And the answer is, oh, somebody else will write it. We have Java, right? That's true, but Java has the Java test harness, or JTrack, right? And they've had this for a long time, even before JUnit came out. It was actually right before JUnit came out. The folks at Sun actually wrote their own test framework. It was kind of Docker-based, and it's still around today, right? It was developed in 1997, prior to JUnit. OpenJDK, if you want to submit a patch to OpenJDK, you may have to write a JTrack test, right? But the interesting thing is the Java technology compatibility kit was entirely built on test cases. And Sun Microsystem and the folks there had the wisdom to say, you know, we can actually sell this. They sold, you know, the test kit as means of making money on Java. And that is interesting. It's not the production code that was sold, but the actual test suites. And there was big time purchases of this by IBM, Microsoft, various companies. But, you know, today, we still don't have primitives for writing test cases. We still don't have, you know, for developers to write tests in general. We don't have, you know, API and SPIs for toolmakers to write, you know, test frameworks, right? And every framework currently builds on JUnit, and they write their own constructs. And this whole idea that testing is unique, it's idiosyncratic. I find that a little bit kind of an absurd, because for me, it's like from a testing perspective, regardless of what you're testing, what you really are testing is, you know, given a certain input, am I producing the right output? And, you know, in addition to that, you're talking about the experience of how fast your code is running, right? And maybe there's performance optimization, things that you might want to do differently. But ultimately speaking, that's what tests, you know, are about. And obviously, there's different techniques that can be employed, but, you know. Another thing is, you know, testing is learned often on the job, right? It's every job, right? Because every job has its own language, it's you know, its own way of communicating tests in general. Universities, right? There's only a handful of universities where they actually have coursework on how to write software tests. And it's generally geared towards people who may want to become test engineers and, you know, testers, right? So the job is where really, you know, we learn how to write code in schools or on our own or whatever, boot camp, but, you know, testing is not one of those foundational things that are actually taught. We can't agree again on definitions of what is, you know, a test case, what the objectives of the test case is, strategy, tactics to employ, and lots of rules to learn. There's so many rules out there. I've had, you know, associate engineers say there's too many rules. I don't know how to manage all this information. You're telling me things that I may learn at you know, in a single semester university, and you're giving it to me in, you know, in a presentation or, you know, just a talk. And there's too much noise and nonsense out there. Really, there is a lot of noise and nonsense. You see people doing all sorts of weird things in general when they're testing their code, and it's very fascinating to see some people in the test cases they write. And oftentimes you'll see they're testing the wrong things. They're doing lots of work that is quite unnecessary. So I actually went and Googled all these terms and just put test under it, right? And this is sort of the word cloud that came out, right? Unit testing, obviously, a lot of people like to talk about unit testing, system testing, performance testing, and beta and alpha and so on. But there's a lot of what I like to call terminology of misinformation here. Like, you know, well, if I ask people what a stress test is, right, I'm likely to get different answers, right? If I ask people performance tests, like there's lots of qualifying statements that are made about performance testing. One of my favorites is you know, two of my favorites, sanity test and smoke test, right? I mean, what is a smoke test, right? I mean, the only people that I know that do smoke tests are firefighters or, you know, people who are detecting holes in pipes and so forth. And it's really not very informative, right? Engineers, God bless them, they're good at engineering, but they're not good at, you know, linguistics and naming things. Sanity test, right? Verification test, right? That's an interesting thing to say. What is I would imagine every test case is a verification of something, right? the validation test. So it's acceptance test. Like, I write tests for them to be acceptable, right? I don't write them to not be accepted, or to verify whatever work I'm actually doing is acceptable, right? So, inaccurate and misleading terms, right? This is filled with inaccurate and misleading, right? And not necessarily that these things, you can Google them, but it's how they're used at various places, right? There's no, definition of what this is, right? And maybe that's okay, but I find that a lot of times if you want to talk about something, you should agree on what it is that you're talking about. Frequently misused. I had a gentleman I worked with who was a team lead, called everything a unit test, regardless of what it was. Every test was a unit test, right? I mean, some tests are not unit tests. Ambiguous terms, right? Like I said, smoke test. I don't know what that is. Wow, this is not. Oxymorons and pleonasms, like verification tests, is just, it makes no sense to me, right? There is a job to be done when we're testing, right? And the job really that is to be done is to deliver acceptable work, right? That's really, from a testing perspective, right? That's what you're testing. You're showcasing that what you're doing, the business logic you're writing, the logic you're writing is actually going to be accepted, right? And it's going to validate.
That's only half the reason.
There is more reasons, but this is what it really comes down to.
But you can do that, you can deliver acceptable work without writing any unit tests at all. Just do manual testing.
You certainly could do that.
But manual testing will never satisfy the other half of the equation.
Yes, manual testing, there's a cost associated with it. And that's the real key that we don't want to do manual testing, is that the cost associated with it is heavy. Right? And if I have to tell everyone how to actually validate changes to the software, because we're constantly changing the software.
But now you're talking about the second half, which is management of the changes in the software, not the original delivery.
Yes, absolutely. But continuous delivery requires continuous delivery of acceptable work. Yeah. So how do we get there quickly? Right? It's because we want to minimize friction, and we want to minimize the time it takes people to get up to speed in order to write high quality code and high quality tests. Use easy to understand and easy to explain terminology, right? These things should be, if they're not easy to explain, and if I said but this and or I have to qualify things, it becomes really difficult to actually start writing test cases. Write easy to understand and explain tests, right? And how do we do that, right? How do we actually, if we have a good enough language that's easy enough to understand, we should be able to write easy enough to understand and explain test cases. Have primitives for tool makers to write test frameworks. We don't have, if I write a test case for, let's say, a web application written in Spring, or a web application written in Jersey, or Drop Wizard, or every one of those has basically their own test frameworks, right? And I have to learn every single one of those things. There should be primitives for tool makers to use. Have primitives for developers to write, right? So on one side you have the producers of the framework, or the general framework, and then on the other hand you have the consumers, and it should feel natural regardless of what tool you're using. And so semantic testing, right? So semantic testing is basically defines terminology for people to actually communicate the objectives, mission, strategy, and tactics for writing test cases. It defines test categories, right? And there's unit tests. What is a unit test? What is an integration test? What is a system test? Safety test, experience test, right? And so all of these things are really, from a practical standpoint, these are the things you really need to deliver acceptable work. And it actually defines what those are, what the objectives of each one of those test categories are, and what strategies you can employ. Doesn't necessarily prescribe what you should exactly do, but it gives you an idea of what you should be doing.
Where would you put regression testing in that stack?
Every test case that I write is actually going to validate some business use case. If a failure happens, I'm going to write a test case, and it's just another test case for a missed opportunity to correct. So the reason why bugs generally exist is because of the misunderstanding of the requirements, miscommunication of the requirements, and so when we make changes, we're making changes based on that. Or, I mean, sometimes developers aren't not really doing a good job of actually fulfilling the requirements in general, right? So these things are opportunity. So writing test cases is part of making sure that we fulfill the task at hand. We actually provide acceptable work. So when we say regression testing, go ahead.
I have a question here. What's a safety test? Like, what's an example of a safety test?
A safety test is, everyone talks about security. Safety is essentially, how should I put it? Okay, so let's say you have a car. It's a Mercedes car, it's locked. It's got all the security bells and whistles, and you can track where it is at any time. But if it's in the middle of a war zone in Yemen, that car is not safe. Right? That car is secure, but it's not safe. Safety says, essentially, I should guarantee that the product does not cause physical injury, does not cause psychological injury, it does not cause financial injury. Because ultimately, you're in the business of business, you're making money. So that's what a safety test is, and it actually goes into a little bit of depth of what actually is involved in ensuring the safety of your software. Now, some of it is not applicable if you're developing a Facebook app. The thing you're most concerned about is making sure that people's pictures are not exposed. Right? You're developing a car, making sure your software does not cause the brakes to go out. Because that can lead to death. Right? So semantic testing, that's it really goes into this. I encourage you to check it out. It's really detailed in terms of what the practice should be, in terms of validating our software. And it defines basically a mission for each of these categories: objectives, strategies, and tactics you should utilize to basically test your software. So it also defines a couple of new concepts. Yeah.
Can you tell us more about the experience based?
Yes. So in any kind of software that you're developing, there's going to be an end consumer, right? And we want to ensure that end consumer has the best possible experience they can, right? So what we have tended to do is actually separate the concept of user experience from day-to-day operation and writing of code. You'll see people talk about performance testing. What is performance testing? Performance testing is nothing more than ensuring that the user experience is timely, the UI is responsive, the load that we can handle is good. When we talk about stress testing, we're also talking about user experience. Everything boils down to really from all the activities that are involved in ensuring the user has the best possible experience. Do they find the product useful? Do they find the tool easy to use? Is it aesthetically pleasing? Right? If you're there are only a handful of people who can get away with aesthetically unpleasant UI. Right? Craigslist is probably one of them, but everyone else, there is a certain level of expectation, right? How things should be, how useful they should be. So when you're testing the software, right, and these are when we talk about experience testing, really these are the most difficult ones, right? developers can do these. These are, the unit tests, integration tests, and system tests are kind of white box, right? Maybe a little bit of gray box testing, right? But these ones really require some level of expertise, some dedication, and you know, some know-how. You know, that like, I'm not going to have a junior developer verify that our system is safe, right? Maybe you could certain aspects of it, but you know, if you want to avoid being hacked, you know, you should have some expertise in-house or external to make sure that you know your data is secure, your network is as secure as it can be, application is secure, the hardware is secure, physical location of your hardware is secure. So all those things are really things that you need to do in order to ensure the safety of your software. So it introduces also concepts of resource types, right? Resource types, so from a testing perspective, right, we have local resources that we as developers can actually spin up locally, right? And then we also have what I like to call virtual resource. The advent of Docker has given us the opportunity to have virtual resources on our machines or a remote location. And then there's remote resources, your cloud resources, right? And then there's collaborative types. So when we think about, from a testing perspective, these would be your test doubles. We have fake, virtual, and real, right? It's simple language, right? Something is fake, that means it's not real, right? Something is real, it means it's not fake. So it's really easy to explain to somebody instead of having to communicate mock, dummy, stub, well, I can't remember, there's a number of them. And then you have virtual resource, right? So these are a hybrid, right? They're basically, they're real, but some portions of it can be fake. Think about a credit card processing service that does not have a sandbox, right? And there's no way for you to test it except to actually get charged every time. In that instance, you may want to fake the charge portion of your in your test case by faking some of those calls, but the rest of them may be okay. Right? So the outcome of some of that work is really Testify Project. It's easy to talk about some of the concepts, but it's really hard to implement some of these concepts. And I was fortunate enough to have some time over the last year to spend on this project, and it essentially takes some of those concepts and actually created a Java project to basically showcase some of these concepts. Implement semantic testing, unit tests, integration tests, system tests. Safety tests and experience tests are really hard to do, so they're still in pending state, right? I've got some ideas of what that means, but the first portion of it is just to keep things as simple and as easy as possible. It provides primitives for developers, and to basically write their test cases, and it provides primitives for tool makers to utilize for their testing framework. Some of the supported projects, right? So, so these are the concepts over here. It supports JUnit 4 and 5. I just added JUnit 5 support. Mocking frameworks, Makito, EasyMock. I would not recommend using EasyMock. I just did it just to demonstrate that, hey, the API there's multiple implementations that can be had with the API to think through the problem, but Makito implementation is probably what you would use. Dependency injection framework, Spring, HK2, and Juice. It supports Spring Boot, Jersey, GRCP, essentially. And with GRCP, literally you can bring your own dependency injection framework with that, and so with this test framework you can as well. Client libraries, I really like Jersey, so I've been using Jersey for the most part as their primary implementation for the client library, SPI. And then virtual resources. Docker, Kubernetes is in progress, so you should be able to spin up Kubernetes, mini Kubernetes cluster for testing purpose locally. With that, I have a demo, so yes.
So question about that. So one of the most important aspects I think that developers are dealing with, or maybe they're not dealing with it enough, is test coverage, which is also an aspect that is kind of, some IDEs supported out of box, some you have to install plugins. My expectations for something like a formal description of testing would also include some expression of coverage. Do you plan to also do that?
So semantic testing explicitly talks about that.
Okay.
Testify does not currently provide direct hooks for providing that information to you. But it's on the to-do list. And we'll talk about the to-do list and things like that in a little bit. So, all right. Okay, so can you guys all see the screen here? All right. So, so this is a simple application. It's a greetings application, right? It looks like a typical application you would see, right? It's got, you know, your basically endpoints, REST resources here. You got your entity and repository and so forth. Greeting, request, response. The application is fairly trivial. It's basically, it takes a greeting object as input with a phrase, hello or ciao or whatever, and persists it in the database, right? And so if we wanted to write a test case for one of our services, a unit test, right, it would look something like this. So here, this is JUnit 4, but 5 essentially is, it allows you to directly just basically annotate the test class at unit test, right? And then you have your, basically the system under test defined here with the SUT annotation. It looks very familiar with Mockito, if you're familiar with it, but it's different in that it actually uses the constructs fake. In this instance, what we have is the system under test, and these are the fake collaborators, right, of the system under test. These are mocks, right? So, and essentially what you could do is basically write a unit test, basically like you would normally in a unit test. And so, we have your, I use behavior-driven development style here, given this, and so forth. And basically, that's a unit test. So I can run it locally, and yeah. And then from an integration test, right? So integration test, we typically want to test integration with something, right? So that means, let's say I have a database and I want to verify that I can save and retrieve data from the database. This is the integration test for the greeting repository, right? So the interesting thing here is that you'll see this declaration of modules, right? So we load the module, if you're familiar with Spring or any other framework, there's the concept of modules. And we can have test modules basically that alter the behavior of the system, right? In this instance, the test module, what it does, it's actually utilizes the virtual resource. The virtual resource here is actually a Docker, basically container, right? And it spins up a Docker container, and it actually allows you to inject your Docker containers API into any actual service. And so in this instance, we're injecting the IP address of the Docker container that we spun up. And we have to qualify. We don't have to qualify if there's only one instance, but yeah, essentially in here, what we're doing is creating a data source instance that replaces the production one. And it actually replaces the production one with our test data source that is part of the virtual resource that we create. And really allows us to basically load test data, do all sorts of interesting things for testing purpose only with our virtual resource. So, let's see. So in here, we also can do interesting things like actually fake certain calls. We can actually fake certain calls here by, if this had a collaborator, in this instance it does not, but if it had a collaborator, we could do all sorts of interesting things with fake or real. We could also inject real instances of other services in our dependency injection framework. And finally, this is a system test. System test tests this basically REST resource or any resource from the client perspective. So in this instance right here, we have the application annotation, a test module, a virtual resource, right? And essentially here, our system under test is a client instance. In this instance, it happens to be a Jersey client web target that's already pre-configured to talk to the server, and then we spun up. And there's additionally the ability to configure any service, anything in the dependency injection framework can be injected into your test case for testing purpose. So in here, we're basically configuring our Jersey client and adding Jackson feature to it. And again, testing is basically the same construct. There's other interesting things that you can do here, which is, let's see here. So you can directly use the web target, right? You don't have to actually go and inject the API. The API provides you with, the API client instance provides you with additional information about the client, and so you can utilize the base URL for whatever purpose you want, but ultimately this is what you care about, the client. You can then make calls to it. Let me see. So there's an opportunity for meta annotation, right? So sometimes you don't really want to see all those annotations, in which case you can have a meta annotation that contains all the annotations. You can create a bundle of all your annotations here that basically describes the test case that you're writing or the feature that you're testing, and give it a more descriptive kind of name that basically is synonymous with a feature or whatever test, whatever you're trying to test.
Sharmarke, question for you. Is meta annotation, is that a feature of the JDK, or is that something?
Meta annotations, no, it's not. You have to basically do runtime checking of
Like an
annotations.
extension.
Yeah.
Cool.
And then here's just a test case that demonstrates the addition of fake instances. So what this is actually doing behind the scenes is it's creating your endpoint, your resource, and it's faking the collaborator. So if we actually look at the update resource here, it has a collaborator greeting service, right? And we are actually replacing this with a mock instance so that we can control it. Like I was saying earlier, if there are certain instances where you want to do this, typically you probably don't want to do this, right? You don't want to actually fake calls if you can help it, right? Sometimes you do it because of constraints that you can't easily overcome. So let's go ahead and just run this. So when we run this, you'll notice that it actually spins up a Docker container, and once it spins up the Docker container, it creates the application. It goes into the application's Spring Bean definitions. It replaces all the production instances that are similar to your test instances, and then basically sets up the data in the database. So essentially, you almost always have fresh new data to test against in a container that's isolated. So every time you run a test, you're essentially running in complete isolation. And that's it. There's not, this doesn't have to be a database. It can be other microservices, right? It can be anything that has basically something that you depend on and has a Docker image you can spin up and utilize in your test cases. Any questions? So yeah, I mean, literally, if your application was not written in Spring and it was written in Jersey, it would look exactly, the test case would look exactly the same. Right? The only difference may be, actually, if you're using Jersey, it looks pretty much exactly the same. So the way you write the test cases looks the same. Yes.
Are you sort of looking at this more, let me take a step back. I often try to distinguish between developer-owned tests and QA tests. I get the sense that this is really more for both. Are you looking at this typically being more useful for developer tests?
So the way I think about tests in general, if you write production code, you should write test cases for it. Right? So I'm not generally in favor of inspecting QA, but there's nothing precluding if you have a inspecting QA that looks at after the code has been produced and does some testing, some black box, they can certainly use this tool. But my primary focus has been is how do I make a developer's life easy? How do I give them the tools they need so that they're familiar and they can withstand basically job changes, right? And you don't have to learn a new framework every time. And you could easily add support for any framework that you want if you actually look at one of the implementations, there's like maybe 6 or 7 classes to support Jersey. There's 6 or 7 classes for Spring. Some of them are a little complicated, but generally speaking, you essentially can support any framework you want, any dependency injection framework that you want. You can support any application server you want.
Yeah, that's good to hear, because I know from my experience, I was at a job where the developers essentially largely punted on unit testing and completely punted on what I like to call component integration testing. So there was a lot of work being done with Cassandra, a lot of custom Cassandra client code, and there was no testing of that. And so all of that was just left to the kid, and I thought that was absolutely unacceptable. And the first thing then I have to say to qualify is, I know it's not easy to do those things, but that it's still, when you take a step back, it's crazy not to do those things. Or to just trust QA to do that.
Did the developers deliver acceptable work?
No.
No. And and they should be writing their own test cases. Right? And you shouldn't accept code from developers that they have no knowledge of whether it works or not, and you have no ability to verify they work. So, yeah.
Maybe one more question.
Yeah.
So that framework really, really makes it easy to write those system tests.
Mm-hmm.
And there might be people who look at that and say, well, why would I write unit tests at all? Because what really counts is how my REST service behaves, and I can test it this way with a system test. So what would your reply be for that?
That's a good question. My reply would be is that you need to ensure the units work. What tends to happen is the complexity increases as you go down to the unit, right? So that the system test itself is really focused on outbound responses to the calling client, right? So it simplifies everything. And you will not necessarily get all the behavior that you would get if you actually tested the actual individual. Your database calls, usually you don't want to propagate those, right? I want to see some test cases that demonstrate, you know, that exceptions are being thrown and something is happening with them. And from a system testing standpoint, you can't really do that. A lot of times, individual units have conditional statements, loops, and you need to actually verify that those things are actually correct. And you can't do that. You can't do that by just writing a system test. Right? One of the interesting things about unit tests in general is that you want to actually verify interaction. Right? So the interaction with other collaborators of the unit. A lot of times when we write unit tests, right? Typically, a typical developer will write test cases after they've written it, right? And at that point, it's like, why do I need to write unit tests at all? But what I recommend is that you actually write the unit tests as you're writing the production code, and that they illuminate some of the thinking that some of your thoughts and some of the things that you're doing. And sometimes they illuminate, what product is telling you is, it's not necessarily correct or doable. And so if you have to focus on the unit. Right? You have to tell me the unit works. Because what I want to do, right, in a code review or whatever, right, what I want to do is I actually want to run the test case, right? And I want to change the input. And I can't do that if you don't write the unit tests themselves. I can't test the edge cases. I can't test any of those conditionals. I can't do that. So I think in general, you want to make sure the unit that you're writing is tested. So I hope that answers your question. I mean, yeah.
No, that's a great answer. The only thing I'll add to that is test-driven development. Right? So thinking about how you want to implement something, your tests can inform the organization. Yeah, that's great. Question?
I was also wondering, I like the concepts that you incorporating into the framework. Like, do you think those can be extended to QA or someone who's not even a developer to generate test cases on a high level? And then, because I know a lot of frustration as far as writing unit tests in addition to code, but it's when there's little business logic or a stakeholder or the ticket is very bland, and then it'd be easier for the developer if there was, just, this should do this, and they just have to fill in their implementation details.
I mean, I would never discourage people to write test cases. I would only discourage them to from writing test cases that don't test what they say they're claiming that they're testing. So if a QA person wants to write tests, and there's an environment in your workplace where you're able to write unit tests, you're able to run these through a continuous, integration, continuous development, process. By all means, we want people writing test cases. What we should do is avoid duplication of effort, right? If a developer is writing, REST resource endpoint, they should test that. Right? They have to test it. Now, if you feel as your organization as we need an extra step to black box test some of those features, then I'm definitely not discouraging that. But I just want to focus on the developer. You need to deliver acceptable work. Somebody else had a question?
Yeah, I was curious about your virtual resources, so like the Docker. If you have data in there and you run like a bunch of test cases, are you allowed to? Do you have to have like the same data? Like, do you have to kind of have the image have the same data for the next test case? Are you allowed to kind of switch
No,
data?
so actually, I missed a step here that I didn't showcase. Maybe this will actually highlight this. I'm actually adding data. Right? Every time I create a container, I'm adding test data. Right? So every time the container is spun up, the Postgres database is spun up, test data is added by the test module. Right? So what we have is literally an ephemeral test resource, but it's only for testing purpose. Every time we spin it up, we're actually adding the data to it. And when we're done with the test case, we throw it away. That's the way I would see it. There's nothing that says you can't build the test data into the image, right? Because the image is gonna, the container that you start, every test case has a new container instance that's spun up. So if you build it into the image itself, it's fine. It just, it's whatever you want to do. I think maybe.
Yeah, that's what I was wondering. I was like, do you kind of build it in the image, or do you kind of sort of do because you did and load it during runtime as it goes in? So think about the trade-offs.
So as a developer, this gives me more flexibility to change the test data and iterate much more quickly. If I have to build a Docker image with all the data itself, it's not as fast. But if you're distributing this test data and it doesn't change at all, build it into an image. It'll definitely make things a little bit faster, although I'm not sure if it buys you that much.
So do you think spinning up a separate container for every test, will it increase testing time very much?
Yes,
Okay.
it does.
Okay.
It does. Right? And there's a cost associated with creating a container every time you run test cases. But there is a solution for that.
Okay.
And it's part of the future work section. Right? So some of the things that I really want to work on is the ability to put applications in test mode. Right? So what currently is the norm is that people create their microservice and you can't really call those microservices without faking them, right? You can't really use them because they have dependencies of their own, and so a lot of times those dependencies are not part of what they distribute. So you have all these services that are in Docker images, but they're not usable without heavy lifting of infrastructure, right? So what I want to be able to do is say, I'm just not going to fake calls to your microservice. I would rather you spend the time and effort in creating an image and the ability to put your microservice in test mode. That means you may want to mock things. You may want to create a container or an image with all the infrastructure in it. If it's feasible. Sometimes it's not. Sometimes you use external resources that are not available. But I want to be able to give developers tools to be able to put their application in test mode. Yeah.
So do you think cloud falls into that also, like specifically PaaS, features or components and stuff like, having a way for developers to really abstract that in some way?
Yeah. I mean, there's also, from a cloud perspective, some of the really good cloud providers, like Microsoft, they have a Cosmos DB emulator, right? So if you actually wanted to test Cosmos DB, they provide this, Docker image for that. But from an implementation side, what I want to do is really give people some kind of a descriptor file, right? My thing is descriptor file, you define if this endpoint is called, return this. If this endpoint is called, return that, right? And now it's on you to basically respond appropriately to my requests. As opposed to me, number one, not calling Microsoft at all and writing test cases against it. Number two, me faking calls to your Microsoft and pretending, the world is all right. I mean, I've seen a lot of people do that. I personally, if I can't spin up your microservice and actually call it directly and have it respond appropriately, I'm not going to test against that, right? Because if I write things that I assume work today, they're likely not going to work tomorrow. And you, the writer of the microservice, is in a better position to know what the responses should be than I am. And you should be able to at least write these responses when I call. This is really one of the things that I want to do is near real-time test execution. You mentioned the time it takes to create a Docker, right? So there's nothing that prevents us from having our test cases submitted as a job, right? To a cluster of servers, or even to peer machines in our local network, right? And so if we have 150 developers here, and they're all on the network, can we actually utilize their resources, with permission of course, to run our test cases inside of a Docker container that's isolated from their OS? Right? So I should be able to submit that. And it's a really quite interesting topic. Distributed test execution run, right? We don't have that. We have JUnit, but we don't have the ability to run our test cases in distributed fashion from our developer laptops. Right? I want a near real-time execution of test cases. I don't want to wait for my test cases to run for an hour or 10 minutes. Or I don't want to push it up to the build system and find out later. I want to know within 1 minute, 10 seconds. Right? I should be able to do that. Speed up start time of virtual resources, right? So you can apply some smarts that say, this user is in active development mode and they're doing all sorts of interesting testing, and so I want to make some of these resources available to them before they even run their test cases, right? And so there's a couple of ways to do that. But yeah. Dashboards to capture test execution metrics, logs, etc. Right? There's no reason why every time you run your test cases, all those artifacts should disappear, right? Why? Why should they disappear? Some people will say, well, I may never want to look at it, but as a manager or as from the other team perspective, I want to know how we're doing, how we are progressing over time. Yeah.
So when I see that, I immediately think, well, isn't that the job of the CI server?
Yes, but does it have to be the CI server, right? Because where I'm talking about from a developer, active development standpoint, right? A lot of the things we currently do is, the build server, you have Jenkins, we have Sonar, all this information is there, but we don't have any of this information handy to the developer right off the bat. Automation of safety tests. Right? This is one of those things where can we apply at runtime some analysis on our application? Can we apply analysis on our network? And can we do this continuously? And how do we do this continuously? By writing test cases for that. Right? Is there a way to do that? I have not figured out yet how to do this, but I definitely would like to do this, right? And we'll see. It's definitely a challenging job. Experience this, right? How do we do it? Tracking user experience is really hard, right? But if I wanted to survey my customers and I wanted to know how they feel, or if I wanted to get feedback from them, right? Can I write test cases for that actually solicits for information, tracks user feedback, and so forth? Is there a way to automate that? That's a possible. And add Java 9, 10, and 11 support. Currently it's Java 8 only, and only because some of these releases have been coming fast. And yes, sorry, go ahead.
I was asking about the experience test.
Yes.
In terms of user experience, so like web services, right? So the user could either be accessing it on the tablet, the PC, like all these different avenues of accessing the service. Is it possible to like objectively test that?
It's a question. That's the question. Is it possible to test? I don't have the answer for that yet. Is it because a lot of it is more or less based on subjective user usage and whether or not they're going to provide you feedback. Right?
So this could be my misinterpretation, but the experience test for a web service is your RESTful responses. Client doesn't matter.
From a look and feel perspective, it does matter.
No, if I'm returning a JSON response,
Yeah.
it's a JSON response.
Maybe I misunderstood. He talked about tablet. I thought he was talking
Right, but
about
he
UI.
specifically talked about, a web service.
Okay. Gotcha.
Yes, and I mean, that's where I was trying to kind of think about the division of the role, right? So an experience test, you explained it as the full experience of the user, right? Then at that end, is it both the back-end testers and the front-end testers like working together to figure out how the full experience is, or is it?
You have to have both. So if there's a UI component,
Yeah.
right, then UI is very hard to automate, right? But theoretically speaking, you should be able to apply maybe some machine learning that can gauge the aesthetics of the UI. Right? I think there's some Google research on that topic where they gauge the aesthetics of UI itself to determine whether or not something looks good or not. I don't know how mature it is, but certainly it's possible to automate it. But from an experience of response time to the actual expected response, you should be able to automate that. Right? But when I talk about experience in general, it's sort of it's heavy on user feedback. Right? How do I solicit user feedback? How do I get it? How do I capture it so that I can actually track it over time? How do I actually, maybe send out a survey and so forth. So it's a very complex issue and topic. Finally, I really want to do this. Create a JSR proposal for Java tests, Java X tests, Java X. I think now you have an opportunity to actually change the language itself with the new changes in JSR proposal. But this is a tall order, but shoot for the moon here. So finally, help wanted. So if you're interested in this topic, there are cool, interesting things that I know testing is not sexy, in general, but there's definitely some clever things that you can do in this area. So if you're interested, let me know. And resource links, Semantic Testing website, semantictesting.org. Testify Project has its own site, Testify Project. There's a GitHub location. There's quite a bit of examples there. So if you're ever interested in exploring some of the other frameworks and looking at test cases, definitely go there. My Twitter handle, that's personal, but if you ever want to get in touch, message me there. And MPR DNA is hiring, so. Questions? Feedback? Okay.
So about 4 years ago, I was at a software craftsmanship meetup, and the question was, testing, among other things, but it was also talking about the utilities of software development, stuff like that, and so we basically had people go up to the whiteboard and write up all kinds of things they thought would increase the quality of their code. And then we all voted. There was probably about 100 of us in the room, and the top vote getter was, you should write your code to be testable without a special framework. Because that forces you to separate your concerns, not have to mock statics and
I'm glad you mentioned that, because some of the SPI and API that's provided here allow you to actually put constraints on the actual production code itself. And you can actually say, you know what, I want every test class to have something that's called me out, if you want, right? You could literally specify some constraints. I didn't want to do that from a framework perspective, but from a user perspective, nothing is precluding you and your team from creating a standard for yourself. So you can say, you can validate that there's no field injection or there's no setter injection. You can make sure your constructor that there's no static. So then you can do all sorts of pre-checks that happen. There's a lot of hooks in the framework for pre-check. And post-check. So I'm definitely mindful of that. I don't want people to write untestable code because the framework makes it easy to. And
right.
I've tried to instill some level of structure, but I favor not being too rigid on that. All right. Well.
So how long have you been working on this, Sharmarke?
So the concepts have been things that I have been that have been in the back of my mind. So I found it painful to teach people testing concepts over the years, and I found myself, using the words real and fake often, right? And I'm like, why the hell am I using mock when I can use fake, right? And so these concepts have been through my head. Unfortunately, the technology wasn't there either because there's really no Docker, and it was very difficult to get some of the concepts off the ground. And so I spent 2017 I took the year off, and I spent part of my time working on it. I don't know exactly how many hours I put into it. I probably don't want to check how many hours, but I definitely put some work in there over the last year or so.
Cool.
One more comment about the UI. Most of you, I hope, are familiar with Uncle Bob. So he has a thing called Architecture of the Lost Years. And one of his comments is, when you say you're writing a web app, that is not a description of architecture. That's a description of what kind of user interface you're going to provide. And so, from that perspective, when you said UI, I interpreted it in the Uncle Bob way. It's like, well, whatever leaves my space that someone's going to interact with, as opposed to an actual GUI.
Yeah. No. Yeah. I mean, again, it's one of those things that there's a habit that has formed, and we've practiced this bad habit of calling things and not having an agreement on language in general. And so sometimes I have to be mindful as well about the language that I use when I describe things. Yeah.
So what do you find wrong about the word mock?
I try to explain it to a non-technical person, like somebody right out of college.
Well, what you say is that, remember in a movie or a TV show, what you're seeing is a wall with nothing behind it.
Yeah, it's unnatural, right? You have to Google a mock.
No, I just want to back you up. I agree with you that, to me, the terms mock and stub both imply the implementation, not the interface.
Yeah. And then, you know, so it's tough language to explain. Right? And everyone like in the industry is like, oh my God, we don't have people testing, right? Nobody ever says, maybe we need to simplify, right? Maybe we can get better traction if we simplify the language, we simplify the constructs. But, you know, rather than just, you know, hey, we're just going to write a new book to talk about the topic, right? And maybe that'll help. But I think for us, from an industry standpoint, we've done a terrible job. I think we've done a disservice to young people in a number of ways, and one of it is we don't teach them in college, and a lot of workplaces surprisingly do not have an environment where testing is expected and it's practiced, and there's an opportunity to learn how to actually deliver acceptable work.
So one aspect that in your presentation you kind of implied, but maybe you want to talk to it, is that if you look at applications that are out in the wild, unit tests are probably fairly standard in the sense of how they're written. Even if some people are testing G and versus JUnit and blah, 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 and easy mock versus power mock versus all the other crap. But one thing that is very likely that you will encounter is heterogeneous environments when it comes to testing, meaning that JUnit you have, but for example, your integration test or your system test, you have like some JavaScript, some I can't even name all of these. You have different ones for performance tests and so on. And there's but what I like about yours is that it's one language to rule them all. Basically, it's one homogeneous environment. So maybe you can talk about some of the aspects that went into that.
So I'll give you a perfect example. When we talk about performance testing, stress testing, you know, load testing, all of these things have one thing in common, right? And that is user experience, right? And all of these things have another thing in common. They may require a number of servers to be up, and they require a certain level of load, right? Why shouldn't I be able to, with a click of a button from my machine, right, and write a test case that says I require 100 nodes, this much data, and this is the data that I'm going to require, right? And I want you to make 10,000 requests per second, and then submit that as a job. Why isn't there a framework that allows you to do that, right? And that's the way I'm thinking about it, right? I don't want to go outside to a completely different environment and spend a lot of energy and time doing something that I may be able to do for my own machine with a language that I'm familiar with a language or constructs that I can carry over into other companies. Now, like I mentioned, the study that that was funded by the National Science Institute. The one glaring thing was that developers lack tools and infrastructure, and that's still a problem. And so that if we can solve that problem, right, I think it makes life much more pleasant. I shouldn't have to use a different framework to test my Azure cloud services or Amazon or Google. Right? There should be remote resources that I can test. And if there are actual remote resources, implementations for it, I should be able to spin those up, use them, discard them. Yeah.
Communication to those remote resources and the your framework, is that only HTTP, or can you like test what's
They under the hood would use basically the SDKs of these cloud providers. Most of them, if not. I'm not too familiar with Google's, but Microsoft for sure, and so does Amazon. So, if I wanted to spin up a Cosmos DB instance, I would use a Microsoft SDK that allows me to do that. And as a remote resource, be able to get relevant information for me to use for testing.